afternoon, everyone, and a very warm welcome to those of you joining us here in Tokyo, and as well as to our global audience tuning in online. I'm Susanna Savage, Agriculture and Commodities Correspondent for the Financial Times, and I'm going to be moderating today's session, Global Food Security in a Changing Climate, Science, Technology and Investment in Agricultural Innovation. Thank you to ADBI and CGIAR for partnering with the Financial Times on this important discussion. First, I would like to introduce Dean Bangbang, the Dean and CEO of the Asian Development Bank Institute. Before joining ADBI in April 2025, he held several ministerial positions in the Indonesian government, including Minister of Finance. Thank you, Dean Bangbang.
Thank you, Sana. Very good afternoon and also good morning to our online and in-person audience, colleagues and friends, depending on from where you are joining this session. As Dean and CEO of Asian Development Bank Institute, it is our greatest pleasure to welcome you to the race for global food security, science, technology, and investment in agriculture innovation, together with our co-hosts, CGIAR and FT Live. Although we have made significant progress in food production, as well as food and nutritional security, there are still over 700 million people suffering from hunger and nearly 2.2 to 4 billion people experiencing moderate to severe food insecurity. Climate change, environmental degradation, fragile supply chains, and volatile food prices are making the task of feeding the growing world population more difficult than ever, which is expected to reach 9.7 billion by 2050. These pressures are especially acute for staples like rice, which feeds over half of the global population. Despite the projected increased demand by 30% by 2050, global rice yields have plateaued in recent years. Some studies indicate that without adaptation, climate change could reduce rice yields in Asia by 10% in 2050. But the good news is that innovation offers hope. Advances in genomics, molecular biology, and artificial intelligence, together with the millions of genetic resources stored in global gene banks, are enabling the development of crop varieties that are more productive, more climate resilient, and better adapted to local growing conditions. Also, AI-driven crop modeling is now significantly reducing varietal development time. Similar approaches can be applied to other crops and regions, building a more climate-smart and resilient global food system. Yet, science and technology alone are not enough. We must ensure innovation that are accessible, affordable, and relevant to the farmers, especially in low and middle-income countries where yield gaps remain high. To do so, it requires open data to accelerate collaboration, capacity building in bioinformatics and advanced analytics, responsible governance of AI and gene editing tools, and sustain public-private investment in agriculture R&D. The evidence is clear. For every dollar invested in agriculture research, returns can be as high as tenfold, and not only in productivity gains, but also in poverty reduction and environmental sustainability. Now is the time for us to think boldly about how cutting-edge science, smart technologies, and strategic investment can come together to transform agriculture. Let us explore not only what is possible, but also ensure this innovation work for farmers, food security, and our planet. Thank you very much.
Thank you very much, Dean Bangbang. I'm delighted now to invite our keynote speaker, Osamu Koyama, President of the Japan International Research Center for Agricultural Science, to share his remarks.
Thank you, Susanna, for your kind introduction. I'd like to thank organizers, FT, CGIAR, ADBI, for giving me such wonderful opportunity. So we are talking about global food security. So what is a global food security? Food security, global food security is an accumulation of local food securities. And the graph, the right hand, shows the World Price Index made by World Bank. It is true that downward trend of real or relative world food price represent the increase of productivity. In other words, the progress of human civilization. But low price or stable price is not necessarily the solution of food security. Food requirements and needs are not the same as market demand. Even in 1980s, when exporting countries competing each other, there are a huge number of malnourished population. So the issue of food security has many dimensions to consider. So there's that's the reason why we repeatedly say that there is no one-size-fits-all solution to food security. So in Japan, price of rice soared sharply this year. There are many reasons behind, because of due to climate change and retirement of old farmers, production has declined, and demand sharply increased by the sudden foreign tourists. But most importantly, Japanese rice market is segregated, partly because of tariff, but partly because of the high quality Japanese rice. Now the Japanese rice is a different commodity from rice which is internationally traded. So we have to consider the local circumstances in considering food security. In fact, the price hike in Japan have coincided with the falling international price. And we'd like to I pointed out that food security always requires consideration of local circumstances. So what would be the solution? I found that subtitle of this event is very interesting, which is science, technology, and investment. So there's no doubt that right investment, or appropriate investment, is the key to addressing our supreme goal of global food security. But I must say that science and technology alone cannot solve all the immediate malnutrition problem, as the social or policy aspect is very important in food distribution. But together with proper setting of institutional measures, the investment in science and technology will be the central role for human food security, in future. And we all know that without proper intervention, investment capital tend to flow to areas with high short-term economic returns. The right-hand chart, it's a the below short-term. The money goes to short-term tangible profit. And investment in highly competitive area does not necessarily benefit the less competitive producers, vulnerable small-scale holders, which has a food security problem, who has therefore policies that redirect investment are necessary to ensure food security. The public and social investment remain indispensable in supporting sustainable production in disadvantaged sectors and regions. That is why public research institutes like our institute, GIRCAS, or international organizations like CGIAR, ADB, continue to exist. So, thanks to the advancement of technology, science and technology outside of agriculture, a variety of cutting-edge technologies are emerging. And some of them are very promising for addressing food security. In Japan, we are now investing a lot in so-called smart agriculture. And technology which combines agriculture with various kinds of data. It aims to solve the labor shortage caused by the aging farmers, but it also be applied small-scale farming in many other countries facing a similar problem. And AI, among others, AI and robotics sensing will be a powerful tool to precision agriculture and customization of technology to local needs. That's very important to address the food security. And advances in genomics, including microbial genomics, are changing agriculture production dramatically. And BNI, biological nitrification inhibition phenomena, which is one of the joint research results between GIRCAS and several CGIAR centers, is one of the groundbreaking example. Okay. In conclusion, to achieve global food security, we need a new global food system in which a diverse agriculture system can coexist, either family farming or big business. So I'd like to hear the following discussion for this purpose. Thank you. Thank you very much.
Thank you very much to Mr. Koyama. That was really interesting and a good way to start. I think we've heard from both Dean Bangbang and Mr. Koyama that climate change is intensifying, and this is putting global food systems under enormous pressure. The question is not just how do we feed a growing population, but how do we do so sustainably? And part of the answer seems to be by harnessing innovation, science, and investing in order to transform agriculture from the lab to the farm. To help us unpack the opportunities and the challenges ahead, we have some leading voices in agricultural research, investment and technology. So first, could I introduce you to Ismahan Elouafi, Executive Managing Director of CGIAR. Then Yvonne Pinto, Director General of the International Rice Research Institute, IRI. Dil Rahut, Vice Chair of Research and Senior Research Economist at EDB Institute. And Razarine China Tiranan, CEO of Listen Field. Thank you very much for joining us today. Before we begin, just a little bit of housekeeping. We're going to take questions at the end from the audience online and in the room. For those of you in the room, please, if you could raise your hand and wait for a microphone, we'll bring one over to you, and then introduce yourself and your organisation before asking a question. And for online, you can type your questions into the box to the right of your screen, and I'll be receiving those live, and we'll bring as many as possible to the speakers. So please get thinking about what you might like to ask as we go through the questions. So I think to kick off, I'd like to start by asking you, Dr. Elouafi, if you could give us, the big picture. From your vantage point at CGIAR, what are the most pressing innovations in agricultural science and technology today? What's at stake if we fail to bring them from the lab to the farm?
Thank you very much, Susanna, and really a pleasure to be with you here in Tokyo. So if we look at the big picture, what we have to recognize first is that the things are not getting well. The numbers in terms of malnutrition, the numbers in terms of poverty, it's really going worst. And the numbers are going worst in the last few years. It's not only COVID, it's not only the Ukraine war, it's not only the latest wars, it's much more, a little bit more than that. And I want to start with that. So right now we have 2.3 billion people that are moderately or severely food insecure. Those are the numbers from 2024. 335 million more from 2019, from the COVID, the pandemic time. But 683 million more from 2015, when we signed the SDGs and the Global Development Agenda. So from the Global Development Agenda, we have been going down, not up, in terms of doing well, in terms of really fighting malnutrition. And the number's going to go worst. If we look at the projection by 2030, 60% of people in Africa are going to be malnourished. If we look at the numbers in Asia as well, it doesn't look good. It's less bad than Africa, but still it's very bad. So then that's really the gloomy future if we don't do anything. Could we make it better? Definitely. How so? Based on science, technology, and innovation. And we have seen it in over the last 60 years. We have seen how the use of technologies, innovation, made most countries, particularly in high-income countries, to produce more with less. But this happened only in certain parts of the world, mostly high-income countries or high middle-income countries. It did not happen in the low-income countries. And that's where really we are here in the TCAD week. And TCAD, it's really about Japan-Africa collaboration. And in Africa, the yield gap is way too high. It hasn't gone down. Most of the increase of productivity in Africa, for example, or Southeast Asia or South Asia happened by clearing new land, not so much by using technology and innovation. And that's really the answer from my perspective. It is an era where we should use science, technology, and innovation much more to be able to produce more with less. And that's where high-tech, AI, genomic, Dean and CEO Bambaraz mentioned it, all those advances in those very, very precise technologies like nanotechnology, genomic, proteomics, AI, digital, all of them as a bundle of innovation can allow us to do that. And to go back to a better world where the numbers reduce progressively by 2050, hopefully.
So I want to zoom in on the hopefulness there, that, the hope that things can turn around. And I'd like to ask each of you if you could tell us about one innovation or breakthrough that you're particularly excited about right now and why it matters for food security. I don't know who wants to go first. Have you got one in mind, Rasoon?
Okay, sure.
Yeah?
I would say that I have seen a lot of growing demand in terms of sustainable supply chain related technology. There are a lot of innovation allowed in terms of improving soil health, enhance crop yield, or data and analytics solution that can connect the supply chain, making supply chain more transparent. And I want to share my journey. I was a researcher before founded Listenfield, so I have experience in terms of how the research in the lab work and how we make the result from the laboratory become the real world solution. I want to share that it's not just about the technology that we realize. We have to think of how we're going to package the technology in the way that is accessible to stakeholders. I want to emphasize that why I say stakeholder. To make a food security is not just about farmers, but it's about how each stakeholder can benefit from the data. And the most important part to bring the laboratory result to become the real world condition, real world product. We need to make sure that we find the early adopter. We have to showcase the early adopter, and then the early adopter can be the showcase for others to follow. And later on, I'm happy to share more on what kind of solution that we bring to farmers in Southeast Asia or in Japan.
Okay, fantastic. We'll come back to that then. Yvonne, did you have an innovation in mind? Or?
Well, thank you very much, and it's a great pleasure to be here as well. I think that you heard a statistic earlier that we have rice production growing at 1%, and we have a need for 30% more rice by 2030. And so you can see that rice is an example, but it's not unique. Across the CGIAR, which is a global family of lots of different types of crops, similar pictures are present. And the CGIAR as a family have integrated their capabilities in science, technology, and innovation by integrating breeding systems with aspects related to market intelligence. Now, we know that 40% of all modern varieties that are grown originate from such kinds of collaborations, and these generate an economic surplus of about $40 billion annually. So that's a really positive example, but I think integrating the market intelligence enables us to understand what farmers' needs are at a global level with all of the local specificities, and to then design our breeding programs and harness everything from the genetics in gene banks to breeding pipelines to engaging with downstream actors to actually speed up the breeding, to enable those traits to address specific complexities, particularly around climate change, enhancing and building resilience and driving incomes that sustain the adoptions of these innovations. So the CGIAR has an accelerated breeding platform that it has developed over the last few years, and that meets the needs of 100 million farmers and consumers across Africa and South Asia. It's crop agnostic. It enables the capabilities to be consolidated. And in the last 2 years, between 22 and 24, 900 crop varieties were released by CG partners across 66 countries. So there are solutions present. I think when we talk about the new technologies, we can actually really fast track our breeding programs by combining and translating both biophysical and social research. I might give you a couple more examples. For example, the International Potato Center, using its market intelligence, identified West Africa as the largest sweet potato breeding region, accounting for 1/3 of global production. And they set up their work in Nigeria to address that. In Tanzania, fieldwork by CIMMYT, the wheat and maize agency of the CGIAR, shifted to meet market demand in terms of the size, the color, and the oil content of their varieties. And I'd like to just mention a little bit about rice, since it's so topical, if I may. In the frontiers of rice breeding, we are improving varieties for climate resilience. We're dealing with high-yielding hybrids, including those that perform in high temperatures. We're looking at healthier, low glycemic index rice varieties to address non-communicable diseases such as prediabetes. And we're tapping these AI technologies to combine elements of precision agriculture, but also for looking at genetic traits, using machine learning to identify them. In the International Rice Research Gene Bank alone, we've used artificial intelligence and machine learning to screen 60,000 accessions in a year, whereas it took us 5 decades to screen 20,000 previously. So that gives you a little bit of an understanding as to the strides we are able to make, the speed at which those happen, and by integrating our capabilities, we can address crops across a range.
I definitely want to come back to AI, but just quickly first, does anyone have any other innovations they'd like to mention? Dil, Ismahan?
Yeah. If Adele, you
Yes.
want to go first?
Yeah.
Please, yeah.
Thank you very much. Actually, I would really like to reiterate what Dean Bambang and also what Yvonne actually highlighted. I think one of the biggest innovations that has happened, actually it came from CG in terms of developing varieties which are climate resilient, which are actually stress resilient, both to abiotic and biotic. I think had that not happened, I think we would have actually suffered dramatically, and our productions would have gone down. Thanks to CG's innovations that they came out with this drought-tolerant varieties, the saline-tolerant varieties, and also like water-tolerant varieties of rice, wheat, and maize that actually helped us sustain the productions. But as I was discussing with my colleagues, one of the challenges that we have is that, yes, I mean, like now we are able to actually make up and we are able to sustain the productions, but there's a limit to which we can actually increase the productivity because the climate is actually beating us. There's a limit to which we can extend. And I think one of the greatest innovations for me is also happened in terms of agronomy systems, where actually CGs are able to develop agronomic practices which are actually reducing GHG emissions, and as you also highlighted. So that's also, I think, a great contributions that agriculture is going to make. So it's trying to actually hit both sides. One is the production side, whereby trying to beat against the climate change. The other one is trying to promote those practices that actually help in reducing GHG emissions and maintaining the global warming. I think these are two important things that's happening within CGs.
Yeah.
And maybe, Susanna, I know we talk a lot about genetics. I'm happy I hear soil health, agronomy. But really, if there is one technology that really I want to single, would be gene editing as a technology. And the why is that as a human being, we have been really focusing and zooming on few species. Whereas and the reason behind is that although we have gene banks, although we know the diversity in nature, you just go out and you can see it by your eyes, breeding was very expensive and it takes a long time. So with gene editing, what we can do is go back to the gene bank, like the example of Erie and rice, or like the example we have right now with the Alliance, whereby we went back to forages and we find 2 forages with the funding from Bezos Earth Fund that reduce methane dramatically, up to 30%. Wow. So it's a really species that has existed, that might have been developed in some countries but not in others. But the fact that now we have the gene banks and we have that diversity, or we can go and collect them out, but we use a technology like gene editing to breed them very quickly. And that breeding quickly in species could go from 15 years to about 3 to 40 years. And it used to cost about 100 million per variety to about 5 million per variety. So you got speed and you got also cost saving.
It seems like there's a huge number of exciting innovations underway, from agronomy to gene editing. But of course, one of the challenges is not just discovering the technologies or the innovations, the science, but how do you get those into the hands of farmers? And I think, Razarine, you mentioned this. Particularly maybe in rice research or in other areas, what are the bottlenecks in that process of transferring new science from the laboratory into the hands of farmers, and so that it really makes a difference? I don't know who wants to take that first, Yvonne. Yeah.
I'm happy to add a couple of perspectives there. I mean, we've all heard about digital agriculture, for example. In this modern era, it transcends language, it transcends different mediums of information flow. Using digital tools here in collaboration with Japanese researchers, there are tools such as WeRise. Erie has developed something called the Rice Crop Manager, so that we can actually use spatial mapping. We can also monitor and validate and report on things like methane emissions. We can use drones. We can introduce mechanizations. We can make rice production more efficient, faster, safer, and more able to judiciously use these natural resources that are so limiting. So I think that there are tremendous agronomic practices such as alternative wetting and drying. It's been around for 40 years, but actually now that the climate is really reducing the amount of water available, it's really come into the fore as one of those major technologies that make it more economically viable for farmers. And at the end of the day, you cannot separate their incomes from sustaining the adoption of these technologies. So working hand in hand with them, being able to speak to them either using digital means, using SMS, using chatbots, using verification and gamification are really the ways in which to bridge some of the gap, making their lives easier, getting them new technologies faster, but also enabling them to use things like mechanization where labor is becoming expensive and challenging for them.
Thank you. Does anyone else have any perspective on the challenges in getting technology into farmers' hands, and also what we can do to overcome those challenges?
Probably I can add upon what my colleague just mentioned earlier. First is like in terms of food security, there are 2 parts. Is like breeding the new variety, and the second part is enhancing farm management practice so that we can enhance the existing variety to make it lead to its potential. For this part, from what we are doing is that we provide the solution to provide the information throughout the supply chain in terms of soil health information, crop growth information, and then be able to provide information across the supply chain. By doing this, what we can get is that the feedback from farmers and stakeholders that how technology be realized in the real world condition. This is really important part that I want to highlight is that the feedback, rapid feedback loop between the real world condition with each stakeholder, that how they can utilize the information and technology will be really important. And the part that they want to realize the technology is that we have to build trust. We have to show them that how technology really be implemented and be able to realize in their local condition. By this, I would give one example that we have collaborating with barley farmers in Hokkaido area and collaborating with Sapporo Brewery. I hope they are one of the sponsors for this event. And, it's like last year they experienced the extreme weather condition that they never experienced before. So they don't know that what will happen. Then with our AI-driven insight, we provide the information to help them understand that this extreme condition, extreme climate, how it impact to their harvesting scheduling. By doing this, then they can have information to prepare the facility beforehand and be able to stabilize the production. By showing them this, then they can trust that, okay, the technology and AI that is far away from them become more relevant from their local context. By doing this, then they can trust from the technology, and this it can build up upon showcase, as I mentioned earlier. Then they can be the influencer to promote this kind of technology among their community. And the important part is that we have to onboard the key stakeholder to realize the benefit of this technology. Then technology can become utilized by the farmers.
Thank you. I love the idea of a farmer influencer. I think we've got Dil and we've got Ismahan. So,
I think like there are lots of technology out there, right? Lots of varieties of wheat has been developed. Lots of varieties of CA technology has been developed. But if you look at the farmer field, it's very hard to find those technology adoptions. We went to the extent of like doing farmers field demo. We took farmers tours. We did lots of studies, and we wanted to scale certain drought-tolerant varieties. We actually use insurance, finances, breeders, like breeding company. But then, like at the end of the day, we realized that the uptake of technology was less than 20%. So these farmers are very, very poor farmers that we are talking about. They are poor farmers, illiterate farmers. Actually, I come from Bhutan. I'm a son of a smallholder farmers, and I know how difficult it is for a smallholder farmer to access that technology. First is the availability. Second is the cost that these farmers have to pay. And the income that they generate by producing this product is, I think, almost impossible to meet. So one of the challenges, how do you make this accessible to poor, marginalized farmers? I think it's about reducing the cost and also producing public goods. That's what CG is doing. And also subsidizing farmers to access this technology. Unless we invest, I think the future of the smallholder farmer is at stake. So it's a humongous challenge, and it's not an easy task. And we have realized it. CG must have felt it too, and all of us have realized, like when you talk about smallholder farmer, and the smallholder farmer that we are talking about is to the tune of 550 million smallholder farmers that we talk about, and they actually they are the one who sustain the food security. So the challenge is how to make this technology accessible to them, not the richer farmers. They have access.
Absolutely, I agree with you, and I think really the cost of innovation, it's a big hurdle for really scaling out and scaling up solutions. And the second one is access to knowledge. And that's where really the next question on the AI and digital can allow us to do that. So we hope really, and we will need a lot of investment. Things doesn't come with small investment. We need to invest in those digital solutions or AI or other as genomic nanotechnology to make solution cheaper. As far as the solution, it's really not at the cost or at the level that a poor farmer or small farmer can afford it. We can't get there. Access to knowledge, that's another area that really CGIAR, but also the UN institution and other organizations are working on. It's to democratize access to knowledge. And that's why for me, technology like gene editing, it was wonderful to see so many universities doing it without any patent so that people can use it. But then the debate around GMO, no GMO, stopped it. So there is a lot of things to be fixed, and we have to look at it at the system level. So it's not one bullet solution, it's many, but you need the right policies, the right regulation, the investment, the private sector, because if you want to lower the cost, as far as it's public, it wouldn't. You need to get the private sector to get to the economy of scale so that it's much cheaper. So there is a bundle of things at a system level that we need to address.
So there's an investment gap and we need collaboration to fill it.
Absolutely, a huge investment gap in the science and agriculture.
Thank you. Yvonne?
If I can add some flavour to that, I mean, we've done some impact assessment work in the CGIAR looking at technologies. The ratio of returns is 1 to 10. For every dollar invested, there is 10 times the return in economic value to farmers and to the food system. So that's just the beginning of the kinds of calculations that we can do to demonstrate. We should get better at understanding how much technology development costs us, but we can also measure the returns. And I would agree with my colleagues that the only way to get the value to the right people, which are the 500 million plus smallholder farmers who enable consumers across the world to have a stable food supply, is to work through partnerships. And that includes all of the actors in the innovation ecosystem. It also includes opportunities to work with countries, country governments, either through their own support functions or through the multilateral development banks, who enable scaling up of these investment packages to actually deliver those solutions. And I think, you know, science and technology has a multiplier effect. And I just wanted to mention one specific example because it's so compelling, building off opportunities like genetic editing and so on. Here in Japan, there is the Japanese International Rice Genome Sequencing Project, where 37,000 rice genes have been made publicly available to enable things like marker-assisted selection, gene editing, and other varieties. And this is all released. So herein lies these global public goods that can be used to create value through partnership and through investment, but also delivering those returns for farmers. And that creates a sustainable food supply globally.
How do we then go about mobilizing the finance to fill that gap? And how do we create the necessary collaborations? What's missing to enable that, to allow that to happen? And after this, I'm going to come to the audience, so I hope you've got questions.
So if I...
Sorry.
Go ahead, please.
I just want to add one more example of how private sector can bring in terms of investment to make the technology be able to access to smallholder farmers. One of our projects in Thailand, we collaborating with Unilever. As Unilever make a commitment that they want to create a sustainable supply chain in rice for their products. Then we collaborating with farmers, local university, impact investor and Unilever. The interesting of this is that Unilever make the commitment and then they invest in the technology that Listenfield developed so that the technology be able to access by the farmers. Local university, which is Kasesa University, as the local partner so that they can translate the knowledge and information that we produce in the local context, local language, that farmer can be more accessible and understandable. And then Unilever pay for the technology, and at the same time they also make the commitment to pay a premium price for farmers. By doing this, then it encourages farmers to adopt into the regenerative practice, and once they adopt, then they realize the benefit of regenerative practice so that it can enhance their yield, which means that it enhance their income and also get the premium price. By doing this, create this kind of ecosystem, then the technology can be realized by farmers and at the same time can utilize private sector to bring in more investment into this kind of research and technology.
Thank you. I'm going to come back to each of you for some closing remarks in a second, but I just wanted to give the audience an opportunity to ask some questions. Does anyone here in the audience, in the room, have any questions they'd like to ask? If not, I can take some. Oh, there's one here.
Hello. Do you hear me?
Yeah.
Yes.
Yes, good morning, good afternoon, everybody. My name is Albi Abit, I'm an architect. It's not my place to be here, but I realized for a Japanese company similar to Monsanto, and I realized that I built a seed distribution center, and they had also the laboratories. They go and get seed of origin, like on the Andes or in the Taklamakan desert or whatever. They bring them here. They have their seed of origin safe, which I built for them, and then they manipulate the DNA, and then the farmers can buy the packages they are selling, and those seeds can only give once the crop. And I was surprised. Normally at the high school or middle school, I learned that from a seed comes up a plant, and the plant gives flowers and starts at the wind. You are all acknowledging that, and I was surprised personally because I didn't understand that why Monsanto or those kind of companies are controlling that the farmers can buy only one package, small package with 7 seeds in there, and then they have to go back to the same manufacturer and pay again for the future, although those seeds could engender different, very much more crop. So maybe somebody in your place can explain me that, but since I finished this project, I am asking this question to myself. I say, maybe there is something to discuss with the farmers. Maybe you can, sir, because your father is a farmer too. And I know that also in France, 60,000 farmers, we had 60,000 farmers like 10 years ago, 15 years ago. Today there are 20,000. So farmers don't have any more means to buy all the seeds or stuff like that, I guess. But maybe you can explain.
So problem with patenting. So
what I may say, the technology that Monsanto tried to patent almost 20 years ago to induce sterility has been banned. So normally now when the farmers have to go back and buy seeds, it's for hybrids. Because in the hybrids, if you plant the seed the next year, you get the diversification showing up. So hybrids are known in certain crops, but they go back and buy it again because the yield is very high with hybrids. But the sterility inducing gene has been banned, and I don't think it will come back because all the farmers are going to be really rallying for it. It has been tried 20 years ago, and luckily it was stopped.
I mean, I think there are so many different kinds of seeds. There are many crops that don't even use seed. They're vegetatively propagated. Cassava, yams, bananas, apples even, right? So it really depends on the crop. Also, I think we have many different varieties that are hybrids, as Ismahan points out. They segregate in the second generation, but they are bought because the yields are generally 2.5 to 5 times higher, and therefore they're economically viable. But you raise a good point, which is that, if, as we have experienced, climate shocks are increasing both in frequency and severity, it's very difficult for people to recover from those events. And so actually we always, in our breeding programs across the CGIAR, look at a variety of different types of seeds that can be propagated to develop seed in order to grow subsequent crops. Very often seed that is for the grain market. But we really try and engender seed production at the local level, community-based seed, women's groups that produce seed, and always at certifiable levels, at quality levels that enable better germination and so on. That's how you feed millions of people. We're not talking about feeding the very wealthy in society. We're talking about food security. So without looking at your packet of seeds, it's very difficult to answer your question specifically.
And maybe to add, the center in Nigeria, IITA, has a breakthrough technology for multiplying cassava that Yvonne mentioned. And that brings the price almost 50 times less, and also in terms of times. You do in 50 days what normally you do in 500 days to multiply the cassava. So when you talk about technology of propagation of vegetatively propagated plant like cassava, it's huge and it's important. The center SIP in Peru now is multiplying, it's using the nitrogen technology for conserving the diversity. And every plant cost us $7 versus before it used to be $110 per sample in the gene bank. So there's a number of technologies that are reducing cost and that are increasing productivity, but we need to scale them up. And the only way to scale them up, more investment in science, more private sector, and more local solution, as Yvonne mentioned. It has to be locally adapted.
Wait, we've got lots and lots of questions from online and not very many.
Science in private sector to maintain those lines is also required.
Yes. Yeah. So one of the questions from online, of which there are many, how can we assess the impact of investments and innovations across diverse stakeholders in the agri-food value chain? So I assume part of that question is, how do we assess that based on the different beneficiaries, one of which might be nature, as well as production, yields, farmers, multiple stakeholders? Do we need a good enough pit stop model to show we're on the right track before long-term outcomes appear?
Mm-hmm. So we have a panel called SPIA, which stands for Impact Assessment, Science Panel on Impact Assessment, which is an independent panel. And we are doing those studies in 4 countries, including Cambodia, Ethiopia, and 2 other countries. And basically what you look at the beneficiaries in terms of income, in terms of nutrition, in terms of people versus private sector, versus, as you said, biodiversity, adaptation or mitigation impact. And those studies are very difficult. And that's why agriculture, it's a more difficult area of investment than medicine, for example, or vaccine. You vaccinated this much, you know how many people you have saved. In agriculture, it's a very complex because it's incremental addition of impacts with many, many technologies. But we are trying to use science in it, use data, use digital to showcase that one for $10 that was mentioned earlier, and see and segregate it. How much biodiversity got better, how much income got better, how much nutrition for this population or those indigenous people or kids. But it's a difficult question, and that's why we have completely an independent panel looking into it and looking at different methodologies.
Okay, thank you. Dil, a question here that I think might be suited to you. What's the biggest single obstacle for investors?
Yeah, I think because I think here we are talking about the cereals, right? That's the product that the public goods that CG system produce. I think one of the challenge here, I think if you look at the investment in this R&D in agriculture, the R&D agriculture investment is about 0.2 to 0.5% of the agri GDP. That's very, very low, and the target is about 1%. I think one of the way to catalyze the investment of private sector is that somehow the public sector investment also needs to step up so that it can actually catalyze and mobilize more resources from the private sector. And second thing is that very important thing is the philanthropy investment. That's also very important to actually catalyze. You see, the thing is that blended finance is very, very critical here because the return on actual like agriculture sector, particularly for smallholder farmers, because of the scale is very small. So somehow to catalyze investment within agriculture sectors, we really need to lower the cost of capital. And the only way to lower the cost of capital is that the private sector cost of capital is very high. It's somehow the philanthropy needs to kick in, And also, the public sectors need to step up. If you look at globally, the public finance in agriculture sectors has dramatically declined, and we cannot afford, particularly in the light of climate change that's happening. So we really need to push the government to step up their investment and really catalyze the overall investment.
We're very close to finishing and running out of time. So I did just want to give everyone an opportunity to round up. And just also in that, if you could reflect on one of the questions which is quite interesting is regarding how you see your mandate. Do you see it as needing to produce enough food and purely focusing on food production? Or do you see it as producing food while helping replenish biodiversity, supporting healthier ecosystems and sustainability? Isfahan, if you wanted to, and if you had any other final thoughts to share with us.
So first, we talk a lot about plants, but guys, we work on livestock, on fish, on chicken, and innovation in those areas is as important. But also protecting the biodiversity of nature in those areas is very important as well. On investment, I want to just say I got numbers from Professor Pardee from Minnesota University. He's writing up actually a paper, so he was very kind to give me the numbers before the paper comes out. Right now, the total investment in research and development globally, it's about $200 billion. That $200 billion in the 80s, the top countries was the US, Japan, USSR, Brazil, Germany, and Uganda. Right now, here's the number from 2021. Number one is China with $28 billion. The US second with $12 billion. Third is still Japan with $7.8 billion. So what's happening, there is a shift in investment. We are seeing more in middle-income countries putting more money in investment in agriculture, and that's a really good move. High-income countries, they are putting less money than before. What's happening as well is that there is the mega nurses in many countries, like the CAS in China, or Embrapa in Brazil, or India ICAR. Those have really advanced a lot. So the CGIAR role, if you want to ask me about the CGIAR role, is different than 60 years ago or 50 years ago. There is a component whereby we are developing innovation, but there's a huge component about partnering with the mega nurses to help the small nurses. Because the small nurses, sometimes they don't have any capacity, and hence they rely completely on CGIAR. Otherwise, their productivity, which is about 10% of their potential right now, would never get better. So there is a huge movement. Things are different from 30 years ago. So we need really to reassess it. And by the end, middle-income countries, low and high, should invest more. The 1%, at some time we were talking about 3%. So hopefully the target of 3% investment in science and technology in the agriculture will be done, because that's the only way forward if we want to really adapt to climate change and mitigate the impact on climate change.
Thank you. Very powerful final words.
Suzanne, I'll pick up your question about what is our mandate. I'm a kid that grew up in Ethiopia in the 80s. The mandate at the time was to stop people from dying of starvation. But really our agriculture system has changed, and it is our responsibility to ensure we don't just raise production, but we do so to enable the environment to prosper, so that we're not doing it at the cost of environmental health. But we cannot just produce more food, because we do have problems arising in society related to eating too much food or the wrong type of food or a more sedentary lifestyle. And so that food must be more nutritious in its production. So our mandate is a balanced scorecard of all of those things at the same time. And in fact, we often deal with policies of these things separately, and we need to integrate our thinking of how we actually create the enabling environment for this to happen. The second thing I would say, and this is part of my wrap-up, is just to say I would agree with Isfahan that the world order has changed. And here is an opportunity as we sit in Japan, in Asia, for Asia to raise itself and manage a leadership position in stabilizing its own food supply. We heard about volatility in rice prices. We heard about tariffs. We have an opportunity to invest in the stability of our own system. And we have to meet that mandate and we have to step up for it because we cannot rely on other people to come and save us. We need to. We have the technology, we have the capability, we have the talent. We now need to make it work for us.
Thank you. And very quickly, if I can, Dil, Razin, if you have anything final to say.
Yes, for me, I think what's important is that, like, 60s, 70s, 80s, 90s, if you look at last 5-6 decades, the kind of agriculture practices that we have actually pursued has led to a great detrimental effect on the environment. We have destroyed our soil. The soil is not fertile anymore. The quality of soil has really, really decreased. And if we continue at the same rate, in another 40, 50 years' time, the entire soil system will be collapsing. The second crisis that we have created is the water. We have depleted the water. We are actually pulling, as if it's free resources, abundantly and using it. Somehow, we really need to think of agriculture practices that minimizes the use of water, and that actually leads to the maintaining the fertility of the soil, not only for our generations, for many, many generations to come. We should actually make sure that the soil fertility sustains, and also the water that we have that actually nurtures the plants should actually be managed well for the generations to come.
Thank you. Razin?
I will add upon that is that I think the sustainable supply chain is really important to bring the benefit to all stakeholders and also to fight with food security. And I want to also mention that the true potential of technology will become true when it's combined with deep local knowledge and also continue collaboration with farmers and key stakeholders, ensuring that the technology remains relevant and effective in the real world condition. In this case, then we can work together to really create food security.
Thank you. Thank you very much. Just to conclude today's session, I think for me a few clear themes really stand out. And one of them is the urgency of scaling research and innovation. And what's needed to do that is collaboration across the public and private sectors, and also investment. It seems that that is absolutely critical, not only if we're going to feed a growing population, but if we're going to do so without continuing to harm the planet and to worsen climate change, and also to adapt to climate change, which is obviously having a huge effect on agricultural systems. So thank you very much again. On behalf of the Financial Times, I'd like to thank our speakers, Ismahan Alouefi, Yvonne Pinto, Dil Rahut, Razareen Chinachod-Taranan, we'll get there eventually, and of course our partners, CGIAR and ADBI, for making this event possible. Finally, thank you to all of you for joining us today, those of you in the room and online. We look forward to continuing the conversation at the next event in the Race for Global Food Security series, which will take place in New York on the 24th of September. So do keep an eye out on the Financial Times website for updates about that. Thank you very much.